Alright guys, we're going to go over the study guide. Feel free to pause the video at any time. Number 1, which equation has the same number of solutions? Alright, so we need to work out these equations, but I'll tell you a shortcut. If you just work out the first 2 steps in solving equations, you'll be able to get your answer. So first we're going to take some scrap paper, and I'm going to work out 9 times 4x plus 2 equals 7 times 5x minus 8 plus x. That's the equation. We want to figure out how many solutions it has. If you look at your answer choices, we really don't need to know what the solution is just yet, but how many solutions we can have. So first we want to do the distributive property. 9 times 4x gives you 36x, and 9 times 2 gives you 18. Keep that equal sign lined up. Do the distributive property on the other side. 7 times 5x gives you 35x. And 7 times 8 gives you 56. Notice we brought down that negative symbol. We also have this x that we need to bring down, and that's going to be involved in our second step where we have to combine like terms. So 36x and 18x cannot be combined because they both don't have an x. Over on the right-hand side, 35x and x are considered to be like terms because they both have an x. So you're going to do 35x plus 1x, which gives you 36x. Bring down the negative 56 and everything else on the left-hand side. And hopefully you'll notice that I have the same coefficients, but different constants. So that means no solution. So just 2 steps, distributive property and combining like terms. Now I need to figure out what answer choice has no solution as well. So I'm going to work out A, which is 17x plus 2 minus 9x equals 4 times 3x minus 3. This is kind of a tedious problem. You got a lot of equations to work out. But again, just the first 2 steps, distributive property and combine like terms. So we're looking for no solution. So I see the distributive property on the right-hand side. 4 times 3x gives you 12x. 4 times negative 3 gives you negative 12. Over here on the left-hand side, we don't have the distributive property, but we do have combine like terms. So I have a 17x take away 9x. 17 take away 9 will give us 8x. So 8x plus 2 on one side, 12x minus 12 on the other side. Okay, now look at the coefficients. Those are different coefficients. So this one is going to give me one solution. It's not what I need. So I'm going to keep going. I'm going to look at answer choice B. So answer choice B, I've got 3 times 8x minus 12 equals 5 times 3x plus 9, some big equations here, plus 9x. So I'm just doing the first 2 steps, distributive property. 3 times 8x gives me 24x. 3 times negative 24 gives me negative 36. Distributing the 5 on the right-hand side, 5 times 3x gives you 15x. 5 times 9 gives you 45. Bring down your 9x. So we did the distributive property. Now we got to look for like terms. These are not like terms, so I come on the right-hand side. I've got a 15x and a 9x. Those are like terms because they both have an x. So 15x and 9x is going to give me 24x. Don't forget about that 45. Bring that down. Now look over here. I've got 24x over here minus 36. Same coefficients, different constants. What does that mean? That means no solution. So that's what we're looking for, is we're looking for no solution. So B, I'm sorry, that's not B, that's actually C. I jumped over there. That's answer choice C right there. Answer choice C. I skipped over there. So this one, I want to circle that one because that has no solution. Now I want to make sure that it doesn't say choose all that apply. So which equation, so that's indicating one equation has the same number of solutions. Okay, so my answer choice is C, and I have my work to prove it. Go on to number 2. Number 2 is a bit wordy, and we can get lost in translation. The fuel economy of a car in miles per gallon depends on the speed of the car it's traveling. A car's fuel economy in the city per X gallons of gas is represented by this. So that is the city. That means you've got in the city, in your car, you're doing 28 miles per gallon. 28 miles per gallon. The car's fuel economy in the highway is shown in the graph. Now this graph goes through the origin, which means it's proportional. So when it's proportional, all you have to do is do y divided by x. In this situation, my y is 80. So 80 divided by 2 gives me 40. So on the highway, I'm getting 40 miles per gallon. And that is a lot better than 28 miles per gallon. So, does the car have better fuel economy in the city or the highway? Well, I'm going to go with highway. Why would you say the highway? Well, I would say the highway is because I can get more miles per gallon. I can get more miles per gallon in the highway. And you see my work out to the side, how I got the miles per gallon for the graph, and I've got the miles per gallon for the city. Highway will definitely be our answer. We're going to get more miles per gallon in the highway. Number 3, solve the equation. This one's tricky because you've got fractions and you've got distributive property. What I would recommend is taking care of the distributive property in this situation. So if I distribute in the 2 there, I'm going to bring down 1/2 x plus 3, keep my equal sign lined up. 2 times x gives me 2x. Now, what you may have forgotten is 2 on the outside written as a fraction would be 2 over 1. 2 times 1 times 5 over 2. The 2's cross cancel, which just leaves me with the 5. So that would bring down minus 5. Another way to think about it is 2 over 1 times 5 over 2. Without cross canceling, you would just multiply straight across. 2 times 5 would give you 10. 1 times 2 would give you 2. And 2 goes into 10 5 times, so you still get the same thing. Now what you can do is clear out the equation with your fraction. So you could multiply everything by this denominator to get rid of that fraction. So 2 times 1/2 is a half. Half of 2 is 1x. 2 times 3 gives me 6. 2 times 2 gives you 4x. And 2 times 5 gives you 10. I'm just going to bring down that negative symbol. Now we need to know exactly what x is. So I got to keep going. I got to solve the equation. So I did the distributive property. I cleared out the fractions. I want to look to see if I can combine any like terms. So I look on this side, I have an x and a 6. Those are not like terms. I can't add them up. I look on the right hand side, I've got 4x minus 10. Those are not like terms. I can't add them up. I go to my next step, get the variable on one side. So I go for the smallest variable, x or 4x. Well, this is 1x. That's definitely smaller than the 4x. So I'm going to subtract x from both sides. 1x take away x, they cancel out. Leaves me with a 6. 4x's take away 1x, leaves me with 3x, minus 10. My fourth step is to undo addition or subtraction. So I'm like, well, what's being added to x, or what's being subtracted to x? And I notice the minus 10. It's x minus 10. So I got to get rid of this negative 10. I'm going to add its opposite. I'm going to add 10 and add 10. 6 plus 10 gives me 16. Bring down my 3x. These opposites are canceling each other out. My very last step is to divide by my coefficient. So I'm going to divide by 3. 3 does not go into 16 evenly. Okay? 3 goes into 16 5 times. 5 times 3 gives you 15. You've got 1 as your remainder, so it's 1 and 5 and 1/3. You could also leave it as 16 over 3. It's a reduced fraction. It's improper, but it's okay. Or you could leave it as 5 and 1/3. Or you can even leave it as a decimal number, 5.3 repeating. So any one of these are great answer choices to put down. The most important thing is you have your work shown. Let's look at number 4. Bradley wrote the beginning of the equation. Finish the equation so that the equation will have no solution. Okay, so we need no solution. All right, so we know to have no solution, and I'll even go ahead and start explaining that no solution means same coefficient, different constants. So on this one, you can see that your coefficient is 3 over 8x. So don't be confused or thrown off that it is a fraction. It's okay. So on the other side, I want 3 over 8x. I need it to be exactly the same. Now, what's also deceiving is this little box. I'm not going to be able to fit everything into that little box. Now, I need different constants, okay? I could leave it like this, and it would indicate that I have 0. Well, 12 and 0 are different. Or I can put any number in there as long as it's not 12. Because if I put 12, that means I've got infinitely many solutions. This question wants us to have no solution. So I'm going to put in my box 3 over 8x plus 0. But again, you can have any number besides 0 as long as it's not 12. Okay? Part B, it says finish the equation so that it will have infinitely number of solutions. Okay, so we've already stated that we need to have, and I'm going to say that infinitely many solutions means same coefficient, same constants. I think I spelled constants wrong up here. Same everything for infinitely many solutions. Okay, so I want that 3/8x, and yes, it's a fraction, but that's okay. I'm not going to get thrown off about it. I'm not going to have fraction phobia. Now, I want, for part B, it to be exactly the same as the other side. So I'm going to get rid of that plus 0. That's for no solution. I need everything to be the same, so I'm going to add 12 up there. Everything's the same, so in that box, I need to have 3/8x plus 12. That shows that I have infinitely number of solutions. Number 5, talking about the slope of the line. It says consider the graph shown. Choose true or false for each statement. Okay, for part A, the slope between point A and point B is the same as the slope from A to D. All right, so A to B is this flat line right here. Well, my slope of A to B is 0. It's a flat line, 0 slope. My slope from A to D is not 0. It has a positive slope. So AD, that slope is actually, let's see, I'm going up 2, right 3. So that's a slope of 2/3. So the question is, the slope points AD is the same as the point slope AD. No, that's false. And I've proved it right there. I've given the slope. Triangle ACF, let's see, where's triangle ACF? Triangle ACF. So that's this big triangle. I'm going to get rid of this smaller triangle that I did. ACF, this big triangle right here, is not similar to triangle DEF. So they're talking about this triangle right here. Well, it is similar. When you have a triangle inside a bigger triangle, it is similar. So that is false. and we can just state that these two triangles are similar. They both have a right angle, and there's your right angle there. They're 90 degrees. They have the same slope right here, same slope, so they are similar. The slope between, let's go to C, the slope between AD, which we said was 2/3, is the same as the slope of DF. Okay, so yeah, it's going to have the same slope. If I go from here all the way to F, let's see, I'm going up 1, 2, 3, 4, up 4. To the right, 1, 2, 3, 4, 5, 6. So if I'm doing DF, that's 4/6. Well, that reduces down to 2/3. So these are the same. AD and DF are the same. So absolutely true. Triangle ABD. Okay, so this triangle right here is similar to triangle DEF. DEF. So that's this triangle right here. Okay? Yes, they are similar. They both have right angles. They have the exact same slope. So yes, those are similar. Okay? And number 6. Consider the graph. What are the y-intercepts and the slope? Okay, so the y-intercept is where it crosses the y-axis. There, it crosses the y-axis at 5. So my y-intercept is 5. My slope, see how it's going down? It's going to be a negative slope. I'm going to go ahead and put a negative symbol there. Now, I've already got a dot right here for my y-intercept. I'm going to find another dot where it crosses in the corner of the square. That's a good one right there. So I have to go up 3. Then I have to go left, which is negative 2, but I already know it's negative. So that is going to be negative 3/2. Negative 3/2. That's my slope. It is a negative line, so negative slope. And then explain how you know. Oh my goodness. Well, the y-intercept is 5. That is the point where the graph crosses the y-axis, and then the slope is negative 3/2 because the graph goes down 3 units and right 2 units. Of course, there's other ways to explain that, but that's just one example. Part B, write slope-intercept form of the equation. So remember, slope-intercept form is y equals mx plus b. Y equals mx plus b. I know the slope and I know the y-intercept. So this slope is my m. This y-intercept is my b. So I just got to plug those numbers in. Y equals negative 3/2x plus 5. Write it in slope-intercept form. That's all I had to do. Part C. Write the slope-intercept form of the equation of the line that has the same y-intercept. Okay, so same y-intercept, and goes through the point 2, 6. Okay, so we're looking for a new slope here. All right, so I'm going to set this problem up over here on the right. I've got y equals mx plus b, and I am going to use, this is my x and this is my y. I'm going to plug that in. So I'm going to put 6 in for y. I'm going to use my slope. Nope, I have to come up with my slope, so I can't use my slope. I'm using the same y-intercept. I'm going to use this x is 2, and my b, that said I'm going to use the same y-intercept, so I'm going to use that 5. I just got to come up with a new m. New m. So I'm going to use my solving equations. I'm going to subtract this 5 from both sides. Okay, because you always want to undo addition or subtraction before you undo multiplication division. So that gives me 1 equals m times 2. these cancel out over here. Well, this is m times 2, and my goal is to figure out what my slope is. So I'm going to divide both sides by 2. These cancel out. Well, my slope is 1/2. There's my new slope. So my new equation would be y equals 1/2 x plus 5. Remember, we're going to use that same y-intercept. They just wanted us to come up with a new slope. And really, I did all my work up there. I could have done it down there. Write the slope-intercept form of the equation that has the same y-intercept as the line that goes to this point. Explain how you know. Well, I plugged in 2 for x, 6 for y, and solved for m. Number 7. Steph and Marina are at the grocery store. Steph buys a container of orange juice for $3 and 4.5 pounds of apples. Marina buys a box of cereal for $2 and 5.75 pounds of apples. If the girls spend the same amount, how much does 1 pound of apples cost? Okay. So, we could set this up as an equation. We could say one side will be Steph and the other side will be Marina. They're telling me that I'm spending the same amount, so that's why I'm setting them equal to each other. Steph is spending $3 on orange juice, then 4.5 pounds of apples. So I'm going to use A for apples. You can always use X. Marina is spending $2 on cereal plus 5.75 pounds of apples. So we just want to solve this equation and figure out the cost of apples. A stands for the cost of apples. So we don't have distributive property. I can't add these up. These aren't like terms. So now I want to get the variable on one side. My smallest variable is 4.5. So I'm going to subtract 4.5a from both sides. They cancel out there, leaves me with a 3. 2, 5.75 minus 4.5 gives me 1.2. And that's 1.2a. Then I want to undo addition or subtraction. 2 is being added, so I want to subtract 2 from both sides. So 1 equals, those cancel out, 1.2a. And then my last step is, and that's 1.2 there, is I want to divide by 1.2. You can use your calculator if you need to. 1.2 goes into 1. I need to move that over. So there's my understood decimal, so I'm going to move it over. So 12 goes into 10. Well, it doesn't go into 10. We want to see how many times it'll go into 100. So I'll just do some guess and check here. Let's see, 12 times 6. 6 times 2 is 12. 6, 72. 12 times 9. 9 times 2 is 18. 9, 10, so that's too much. 12 times 8. 8 times 2 is 16. 8, 96. Okay, so 12 times 8 is 96. Subtract 96 from 100. And you can just ignore that decimal right there. So we're really treating that as 100. So 100 take away 96 would be 4. Add a 0. Add a 0. 12 into 40. 12. So maybe 5. 5 times 2 is 10. No, that's too much. That's 60. 12 times 3 is 36, right? So that gives me 36, and I believe my 4 is going to keep repeating. All right, so if my 3 keeps repeating, that means that my A would be about 83 cents. 83 cents. I'm not seeing 83 cents, I'm seeing 80. Okay, so as you notice, I came up with 83 cents. Well, that's not any one of the answers. It's close to B. Now, look right here, I made a mistake. 5.75 take away 4 point. That should have been 1.25. 1.25. So right here, instead of 1.2, I should have 1.25A. And down here, I should have 1.25A. So I'm going to divide by 1.25. So, grab my scrap paper. So 1.25 into 1. So that means I gotta move it over 2 places. 1.25 does not go into 100. How many times will it go into 1,000? So 1 divided by 1.25 gives us our 80 cents right there. 80 cents. So not 83 cents, 80 cents. Okay, so just ignore that. You're going to do 1.25 into 1. And the last one, number 8. Eliza takes a spin class. The table shows the function of the distance Eliza rides if she spins at a constant rate. Use the information in the table to make a graph representing the number of minutes on the horizontal axis. Be sure to label your axis. Okay, so we could use graph paper, or maybe we can just make a little graph right here. This is my x-axis, this is my y-axis. So we're going to put x as the number of minutes, and we're going to have y as your distance, and that's labeling your x-axis and your y-axis. Use the information in the table to make a graph representing the number of minutes. So I just need to plot these points. They don't have to be accurate. So it looks like I shouldn't go by ones, but maybe go by fives. 5, 10, 15, 20, 25, 30. And same thing with your y. 5, 10, 15, 20, 25, 30. Indicate that you're going by fives. So 5, 10 would be right there. Nope, I got that backwards. Because that's my x's, so 10, 5. Think about your ordered pair like this. 10, 5. 10, 5. And then I've got 20, 10. So 5, 10, 15, 20, 10. And then I've got 30, 15. 10, 5, 10, 15, 20, 25, 30, 15. So 5, 10, 15. So you can see a constant rate. Constant means it's going to be linear. It's going to be a line. And then 40, 20, 10, 20, 30, 40. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So let's see. 10, 15, 20, 25, 30, 35, 40. So 40, 20. 5, 10, 15, 20. 5, 10, 15, 20. Probably went too high on this last one. 10, 15, 20, 25, 30. So that should have went up. 15, 5, 10, 15. So yeah, we were just a little too high on that one. Using graph paper would be best. I'm surprised they didn't put a graph on this one for you. And then 50, 25, 35, 40, 45, 50, all the way up to 25. So 10, 15, 20, 25. Find the slope of the graph. All right, so you can use any 4 of these points. Remember, your slope is your second y minus your first y over your second x minus your first x. Okay, So I would use my first 2 points. I've got 10 and 5, and I've got 20 and 10. And a lot of you like using the table. You can see that you're going up by 5 down here. And we're constantly going up by 5, constantly going up by 5. So this is constant down here. The top, we're going up by 10, up by 10, up by 10, up by 10. So remember, your slope is your y over your x. So it'd be 5 over 10. So 5 over 10 reduces down to 1/2. So your slope is 1/2. Explain what this slope means in this situation. Well, the slope is talking about the distance in miles that Elisa rides each minute. So going back to the situation, Elisa takes a spin class in gym. The table shows the function. Remember, a function is where your x values do not repeat of the distance Elisa rides if she spins at a constant rate. Constant means it's linear. Function means your x values do not repeat. So this 1/2 is representing the distance in miles each minute. Distance each minute. Distance each minute. No E. Okay, thank you.